different companies. Okay, so this issue of communication between the design group and the fabrication group become more serious and more critical to your compatibility. So I think it is important for all of us to be familiar with this sort of techniques, which means how can you manage very complicated project information, including geometric information, which most likely derived from a modular like Rhino or like Revit. But besides this geometric information, we also have a lot of information which are not likely to be modeled in a geometry modular. And this information can be very efficiently managed by database system. Okay, and Susan is going to show you how. And maybe for some of you, this might be the first experience in using database management system. Okay, and let's welcome Susan and thank her.
Okay, thanks to Professor's introduction. Okay, so now you've got some files from Moodle, right? Okay, and here, am I screen share to all of you? Yeah?
I think it's already shared.
Okay.
So you can look at the monitor nearby you. So you can take a look and then also work on your own computer.
Okay, so this view, element-based record, is a very quick introduction to you. So in this image here, you can see a table, like a spreadsheet in Excel. And we have records in row. So each row is a record. And each record will contain 3D model, 3D mesh, and other non-geometric data. Also, you can see here we've got a LOD 300. It's a child record of each record here. But the detail you will learn in next few weeks. So in this week, we will keep everything simple so you can know the overall concept of Airtable. And in this scenario, each record, like PE, the first row in the table, in this record, it contains single elements, which is this one, highlighted face here, and others as well. So this is very brief to the Airtable. And if you got an account in the Airtable, and I think all of you has received the join base link, invitation link already, so you can join to this Airtable base, which is created for this course. Please go on. Yeah, please explore into this base. So everyone could log into this base, right?
But make sure you can link to Airtable and log on with your account, and then enter the base which is shared to everyone. Okay. 就先让柔轩，他介绍一下那个 Airtable 怎么样用，然后他们结束再请你帮忙。现在每一个间隔，现在等于是错开梅花间，然后旁边这个是广播的荧幕，然后这个是可以在上面作业的。 Is it okay for everyone? Are you able to log onto your account in Airtable? Is it okay? Yeah. Okay. Yeah, I think Susan can go on.
Okay. So now I'm in the table of LOD 100. So you can see we got two records here. One is called reference surface, and the other one is reference grid. Okay, what's the difference with these two records? We don't know what's inside of this record, but we got some 3D model and 3D mesh here. Later you will need to download this one, but for now we can take a look at what is inside of this reference surface here. Okay, so I assume that you got another link. It's a model previewer which can retrieve the data in the 3D mesh. Do you got this link? Or maybe you can just type in. It's very simple. For the ID of this course, ad5228701.anydate.com.tw. It's a model previewer to retrieve data in Airtable. Okay, so now I can take a look of LOD 100 table and see what's inside of this Mobius reference grid. Okay, after I click load, the button of load, I can see here is the grid model here. And if I want to see what's in the surface, I can load the model again. Okay, so I got this. So now you know in LOD 100, in this table we got two separated records which contains, this surface contains a surface, model 3D mesh, and the other one is grids. So we separate different different elements into different records. And here you see a LOD 200. This is a linked field to LOD 200 table. So if we expand this cell, you could see here, this reference surface contains zone A, zone B, and zone C. And what is inside? Let's click here, and you can see this pop-up window said that we are linked to LOD 200 table here. If we jump to here, you could see we got three different records. So zone A, zone B, and zone C represents different zones of this surface.
Okay.
And
1 minute. Let me explain. Okay, why we are doing this? Because our exercise or our project will be designing and fabricating an envelope for this structure. Okay, I suppose that you have all seen this structure in front of this international building, right? Okay, so right now we have only the skeleton of it. Okay, and I want you to design a surface or the skin of this skeleton, and then make use of this database system to share information with each other. Because right now we have 3 teams, and each team will be responsible for some certain area. So the entire surface of this mobile strip will be divided into 3 zones: Zone A, Zone B, and Zone C. So for load 100, which is corresponding to the level of development in B, in building information modeling, in the concept of this building information modeling. And level of development means depending on our design progress. At the beginning, we have a very rough model because we have very little information regarding the design. For example, at the beginning of a design project, maybe we have some decision on the building mass, on the location and the height and maybe the ground floor plan or the typical floor plan for the entire building. So we have roughly only the building mass and the location. And we don't know where are our openings, we don't know the structure system. Okay? So at the beginning, this very early time, we have very abstract model for the entire project. Okay, and the model are supposed to be further developed along our progress, design progress. So when the time moves on, the model becomes more and more detailed, which means we have more and more design decisions contributed into the information model. Okay, so this is how the term level of development comes. At the beginning, we have load 100, which means very early, probably about the site planning stage. And then we have load 200, which is more or less equivalent to the preliminary design stage or conceptual design stage. And then when we go on, we move into load 300, which is about the detailed design. And then maybe load 350, we start to transfer to the construction company so that they can start to build the building. Okay? And then load 400, probably responsible by the construction company and engineer to make more detailed project information regarding construction. Okay, so this is the rough idea how this load 100, 200, and 300 goes. Okay, and the detailed or very clear definition of this 100, 200, 300 probably can be kind of project dependent, which means the standard might not be universal. So for a small project, okay, it's slightly different from a larger project and can be very different from a huge project. Okay. So load 100 corresponds to the most abstract level of the building, which means we regard the entire structure as one single element. Load 200, then we start to divide zones for collaborative participant. Okay, so right now we have 3 teams responsible for each zone. Okay, right now we still don't know how these zones are going to be divided. Okay, and I think today, I hope that we still have time for some discussion, so each team will present your concept, what you think is, you can run, can do for the skeleton, for the envelope of this structure, and then I hope that we can come up with kind of collaborative design, which means each team can further develop your concept into the real thing, probably using different material, different way of construction, but still combined together we can complete the whole project. So it depending on what kind of material or what kind of construction used, maybe we have different way to divide the whole area into 3 zones. Okay, so we haven't done this yet, but we expect that after our discussion, so we all know what the concept of other teams, then we can come up with a good dissection of the entire surface into 3 zones. And then each team will be responsible to make the surface of the your corresponding zone. And then that will be load 200. Okay? And then for each zone, maybe each of you, maybe we have to further divide each zone into panels to cover the corresponding zone. Okay, and then load 300 model will specify the construction of each panel. Okay, and then we can go on for load 400, which means for each panel, a panel may consist of many elements. Okay, some of them are linear elements, some of them are surface elements, or even some of them are volumetric elements. And whatever you need to describe or specify the construction of every panel more into detail. And this detail will be in load 400. Okay? And then we want to use database to manage all the information. And not only the 3D model. Right now we have only the 3D model. But thinking, if we are moving into the fabrication stage, we need shop drawings. We need something like a G-code to control the CNC machine so that you can fabricate material so that you can make the panel that we want to install onto the structure. So there are more than just the 3D model. And how are you going to organize all this information? Okay, so we can make use of this database management to organize all the information. Okay, so this is kind of the background knowledge. I hope that you have an idea so that you can understand why Susan is trying to introduce this Airtable database.
Okay, so now you can see the model previewer here. We have loaded the Mobius reference surface grid here, and I also load 200 zone A to here, looking like this. And if I continue load zone B here, I will add this part. Load zone C. So now in this model previewer, we can see the whole, the entire surface are covered with 3 zones. Okay, so in this week, we will learn how to query records, how to preview it in the model previewer, in the in this link. And also we will, after we confirm the query results, we can download the 3D model, and then we can open it in Rhino, and then we can do further development. So today we will use here. Let's download this one. Okay, we got Mobius reference surface here, right? Okay, if I want to preview the result first, then download, I could go to the query view here and using filter. And the filter gives you some different fields to filter out. For example, if I'm going to filter the EID contents surface, so I can left this record here. Okay? Yeah, please feel free to try this. But let me demo you first. So if I filter EID content surface here, I could list this one, this record here, and after I get table, and I load it. I confirm that this surface is what I wanted, so I could download this Mobius surface in 3D model field. So I can download this. This will give you a 3D the Rhino original format here. So we can go to the Rhino. And then open this up. So you can see the surface is here. Later we will try to divide zones on this surface. Okay, so please everyone, you could try query on Airtable, and you could try preview the result here, and then you can download the 3D model here. If you need any help, just call me.
你们说大概你几点补习离开？OK，然后关门，所以让他对比较顺效。
哦，OK。
怎么下载的？不知道怎么下载。Double click一下。
可以点在那个好像的手机上。然后被打住了。
对的。对，对的。好，这么。直觉。
Okay, I think that some of you might face different problems. Maybe I'm not so clear in the views here. Okay, so I will make it clear this time. So for now, I am in load 100 table here, the first table here. And let's use grid view to list all records in this table. And we will use query view to query or to filter some certain conditions for the previewer. Am I clear now? Yeah? If we are in the grid view, we could also do the sorting or the filtering, but the model previewer is only reading the data in query view. Okay, so it's little confusing here, but because we want to make sure that the user filter or the user query actions is can be passed to the model previewer. We don't want the model previewer every time it loads all the data or all the model here. So I use query. This view can store the filter result in this query view. Am I clear? Yeah? Okay, so every time if we go to the load 100 and if we get table, let's click get table, and here it said load 100 is selected. Means we are selecting this view, and then let's load the model, and you could see the surface model is currently being previewed. Okay, so but if now we don't want this, we don't want this surface, let's change the filter in the query view. Let's say I want to take something that EID contains grids. So in this query view, someone are changing this, right? Because all of us are collaborating in the same base, so everything that you change will affect to others. So yeah, you could try everything here. But if at this moment I'm changing the filter and I'm querying this, but perhaps someone have changed this, and then maybe you will get different results.
Which means people cannot work independently.
I think I could add one more input here. Let's say we could have different views for different users.
Okay, so the views are shared.
The table are shared, but the view could be
Table are shared. The view also are shared.
yeah, view is shared.
Okay,
but you
so
could lock
we
the
need
view.
to have some kind of convention or rules upon usage. Okay, there can be shared views, which means all of us want to get similar information. Then we can simply use this shared view. Okay, and in some cases, we need specific view or specific information for specific purposes. And this might be for your personal needs or only temporary needs. Then it's better not to change the shared view because it is shared by everyone. Then we can have like a naming convention, like you put your initial, your name in front of the view or whatever. Maybe Airtable might provide some functionality for us to manage our views. So for example, maybe we can set the editability. Some people can edit the shared view, but not all people. Okay, this we still have to figure out because Airtable, I mean, it's not kind of very mature commercial package. I mean, it is free of use for everyone. So we still need to explore what kind of thing we can do. Okay, but for our introductory exercises, I think this is good enough. Okay. Okay, so view are shared. So if you change the content of the view, everyone is going to affect it. Okay. And if you want to create some view for your own purposes, then maybe you put your name in front of it instead of editing the existing view for everyone.
That's a good idea. Okay, so now I'm going to clear this scheme here, and then I will get the table again and load it again. So now I get grids here. Okay, and some of you are trying to select zone A, zone B, zone C in load 100, which is not possible because the zone A, B, C are stored in load 200 table here. So you can go to grid view. We will try to see all of these records here. And now I think maybe someone changed this. Okay, so zone A, we will make sure the zone is zone A and zone B is assigned to zone B. Okay, yeah, we can have other records here, and you will practice this later. Okay. Okay, so now I will go to query view here, and I will use the filter to say, okay, where zone is zone B. Okay, I confirmed here. Then I go to the model previewer. I will keep this grids here, and then I say I want to get 200 table here, and then I can load. So here in this model previewer, we could see zone B is attaching to this model. And if I want to say, okay, where zone is zone A, and then I can do again get table and then load it again. Yeah, that's all. Query, preview, and later if you confirm your query result here, like I have asked you to download the surface model, right? So you could expand this cell here, and this cell is mobile surface.3dm, which is the Rhino original file. So we could press this button, download, and you will get a Rhino file, perhaps is stored in the downloads folder in your desktop. Do you all need some more time to try it out?
Have you shown them how to load this file into Rhino?
Not yet. Open, just open.
I would suggest you can use attach, so that it is attaching to the file as a reference, which means you cannot change anything, but you can see it, you can access it.
Is it insert?
No, attach. When you drag the file into this Rhino environment, yeah, you try to do that. Yeah, you drag the file and put it, and then you say attach file.
Okay, let's open a new Rhino file, then we use attach file. Okay, so now we cannot do anything with this, right?
You can see it, but you cannot edit.
Yeah. Also, we can select.
You can select. Okay, you can turn off the layer so that it will disappear, but you cannot modify it. For example, I mean, in this case, the skeleton, as an envelope designer, you are not going to change anything on the skeleton. So, but you need that file as a reference. So when you say attach file, which means your working environment is connected to the file through reference. Okay, so you'll be able to see it, you are able to access like the endpoint, or you want to snap to a curve, whatever, you can do that. And you can, I think you can copy it. You can make a copy, but you are not going to modify the content of that file.
Okay. So now we are attaching this mobile surface here, and we will try a very simple dissection to this surface, and then we will make it to divide to 3 zones. Then we will export after we divide it to 3 zones, we will export both 3D model, Rhino file for each zone, and also we will export a mesh as JSON format. So 2 files will later be uploaded here in load 200 table. We will create new records. We could enter the element ID here, and we can upload 3D model and 3D mesh here. This week, we are doing this manually. We could explore the interface for, provided by Airtable, and perhaps next week or a few weeks later, we could use Grasshopper to update our data, geometric or non-geometric data, to Airtable. So this week, we will learn how to create records manually. Also, you could see different zones. Yeah, you have seen it before. And maybe you could enter your team and who uploaded this file, this record. You could select your name here. Yeah. So let's. Okay, I got this page here. Query and preview. Yeah, you all know it. So now we are going to open this file. I think I have provided this to you. Okay. I
The
think
first one,
it's
this
this
is
one.
the zip file.
Yeah, it's a zip file. Have you all downloaded? Okay, so in this today's date file, we got something to do here. First, I will need you to open Grasshopper and go to File, Special Folders, Component folder. It's a plugin library here. We could place this Triceratops. It's a plugin provided to export mesh to JSON format. This is for making our surface or our zones to mesh So we could upload it to Airtable. And this one, in this model previewer, it's using 3JS to draw this 3D model for our web preview. So this one, it exports mesh to JSON schemes. So let's copy this, copy, and then paste to our Grasshopper component library. And make sure the property here, if we have some unlocked, check, please check that. Make sure the attribute here is like this. After this, we will need to reload the component. Misspell it. Okay, let's close the Rhino and reopen it. So this Triceratops will be loaded into Grasshopper environment. Okay, you might now see the Triceratops here. Are you with me? Or you need some time?
My internet connection.
Lost? Your internet connection lost? Close the
How to reopen it?
yeah, you can reopen a new window. Open new window, not new tab.
Oh, okay.
Yeah. Then you could enter your
Oh, okay.
Are you with me? Please install the Triceratops to your Grasshopper component library. May I go on? Okay, if you are ready, then we could open this exercise Grasshopper file here. I'm more comfortable to use draw icon display mode, so if you need oh, we don't have Firefox here. Okay, I assume all you could know how to use Grasshopper, right? Okay, so we will use the surface to store this reference surface here. Did you see what I've done? I dragged this surface here, and I said I want to set one surface, and which is this, the Mobius reference surface that we have attached into the Rhino file. I want to reference the surface to Grasshopper. So I could do dissections using this. Are you with me? Yeah? Need any help? Please feel free to let me know if you need any help.
Where to copy the design box?
You didn't open any file here, right? So let's you got this. And you can try this surface to represent this.
How to make it reference this?
How to make what?
Can you repeat the distance, please?
Okay. So let's click this surface. It's a container. Yeah, to store surface inside this. And let's click right. Yeah, and then set one surface. And now you can see here surface to reference. And you click this one. Okay, yeah. So now you have referenced the rhino surface to graph.
And should I connect it?
I will say that.
Okay.
这个，所以我们从 database 抓下来这个模型，就可以到这里，然后这个就把它切成3块。那要怎么样切？其实我们可以在这个设计可以切成不一样的。好，然后再往下走的话，就是它会讲说，切成3块之后，然后再把它产生一块变成是一个独立的一个 Rhino 档案，所以它的 element base， 然后这个独立的档案再送到一个 type 去。好，那 suppose 他们分组之后，他们会需要决定他们怎么样分割好了，或者说做好了再送给虽然做是这个程序是有点麻烦，不过因为一边也在开发，所以所有的工具都是要掺杂很多手工在里面。不过他们也需要，有时候学的时候应该要从 low level 学起，然后才会。 我一开始就用很好用的工具，
这些工具都是适合这个产业。
应该算是我们也是一边摸索啦。目前的好像目前看起来，即使说像 Rabbit 这样子，它处理大量资料，它都还没有真正跟资料库管理系统结合在一起。
现在只有做 information recording。
对。就是像地理资讯系统，其实我后来才发现，即使是外面那些公司，他们也不是从最底层开始，他们都是用现成的那个已经被人家规划成地理资讯系统，然后再来做接续。真的像学会这样直接用资料库来弄，但一般都没有这样做。所以最后他们开发的系统事实上都被那些应用系统给绑死。
除非是做 open source 的。
因为像很多，比如说地方政府，他找的那个公司来开发 GIS， 最后那个政府使用单位说他们想要做什么做什么，但是开发公司两手一摊，他的系统没有这个，就不知道怎么办。
Okay, let's move on. So this reference surface here, I have internalized the data, so maybe you could delete it. I will delete this as well. Okay, so I'll do the reference surface again. So we use the geometry where is it? Surface. It's a container that you could reference surface into it. Okay, so I will right click the mouse and then I will set one surface, and then we are in the Rhino view. The command said surface to reference, and your mouse is looking like that. You can click this surface. So now this component has referenced the model, the Rhino surface into this container. Okay, so I will not going to very detail at the dissection part because we are just showing like if we are dividing the surface like a strap here. So now we got 3 surfaces from the output here. So I assume that all of you will discuss how to dissect the entire surface. So I will move on. Yeah, is that alright? Now I will use what's this? List item. This list item I have give team ABC, like the data inside actually is 0, 1, and 2. So 0 will take the zone A, is here, and team B will take the zone B, and team C will take the zone C. Now, this cluster will let you to export. For example, we are now exporting zone C here. Okay, so this surface is sent to here, the breadth, and we could choose the color here, the color is for the mesh preview on the model previewer here. Okay, so you could try to change the color, and we will need to have the file path where you want to save the file on your desktop, and also a file name. Okay, so now I will just simply save my file in this place. Okay, I will copy the file path and put it here. And then okay. The file name, okay, now it's Team C, so my file name is Zone C. When you confirm the file path and the file name are ready, you could click the button. Okay, let's click the button, and you could see the Zone C JSON file is already in your folder. If we got lots of different zones to export, we could use different data structure to do that once, like click once, and I'll get 10 or 100 files export to here. But now I assume that each group are only export one surface. So now we are using this item here. So please try it here. You could choose different zones and try to export to your local file.
So if someone add the file to Zone C, then everyone will get it.
Yeah.
Right.
Mm-hmm. Or you could
I add one more record.
yeah, you could add one more record to store your file.
Okay, if you open log 200 table, then you can add one more record and perhaps put your name in at the front. I mean, for EID, for example, here I say SHIH zone
Yeah, and find
C.
your folder.
And then I will have 3D mesh.
Oh, okay.
So, Susan,
Yeah.
for the JSON file, we drop it to the 3D mesh, right?
Right.
Okay.
3D mesh.
So I can basically drop it.
Yeah. You can drag and drop the file like this, but it's a kind of hard to put the file at the right place. So I suggest that when you adding new records here, okay, I click plus to add new record, and when you want to drop files onto this record, you could either expand this style, so this will more easily to drag the files to upload, or you could expand the records. If you expand the records here, it is a record for all different fields you can maintain in this view. So you can drag your Rhino file here, and you could drag your mesh file here. Okay, yeah. Let's try it.
Susan,
Yeah.
I think I might miss something. Now I want to show this file. So I select it.
You have, if you want to display on this record, you have to view
Oh.
only this record.
So I have to create a view. Go to the print. so this is for lot 200.
Yeah.
So actually I should add one more for my own.
No. Ah, yeah. Yeah, I have to do that. Ah, no. And now, no. 因为我现在拿到的图书馆只有设计，这四个是如果你有扣钱或者修剪，没有办法知道，那这个 credit 的 view 也是叫做 credit 的这个 view 也是好的，所以它现在只会读其中一个 table。
他只会读这个 table，会读这个 table 里面。
对
credit view 只有一个。
credit view 只有一个，它会读叫做 credit 的这个 view 里面的这一行。所以如果现在这里有做别的，现在剩下一个。
对，现在每个人也都只会看到这个，这有点奇怪。但是这很奇怪，这我们
那个黄色的
这两个在使用的时候 table 是共用的，但是 view 应该是你可能是你该能力不会。
哦，所以应该要自己做的是，它其实是可以把这个电脑，哎，你想到？你可以做一个，就是
哦，它有 collaborative view，然后，所以我理论上我应该是做一个 personal view，然后在我 personal view 上做我要做的事情，然后你的这个程式可以让我连接到。
对，所以我。
5, 6, and then you compose them all together. And in order to confirm whether when there is an issue regarding to maybe some element might be inadequate or might be deformed during the assembly, so you can trace that individual element by scanning the QR code on each element. So when we do the ordering, the GUID number has been generated and then transferred into a QR code. So whenever you see hundreds of laminar strips in factory, or you see hundreds of built up laminar strips on site, and you want to replace a particular strip, you just scan the QR code and you find the order for it. And you also can see the reflection in a 3D model and identify a specific element in a 3D model. That's the purpose of your study for this class. And I will not go too much about the detail of the machining and assembly because this is something that has been done. I just try to explain to you that the recording and the technology that you can learn are able to fulfill your dream if you want to do it from zero to something. And our data can be so useful that you can produce a material chart, we might call it as a material block, and then a data for machining and the data for your assembly. Before assembly, you can rearrange for your raw material, fabricated raw material, we call it semi-finished strip, and then become an assembly zone, and then become a semi-finished from 3 segments. So you can generate all the material cost plus your labor cost. So every process, every step, you can generate the cost by keying the cost with each element. So then automatically you can get a cost estimation before you do anything. So this is telling you that the segment 1 is composed with zone 1, 2, 3, and then segment 2 composed with zone 4, 5, 6, and then segment 3 composed of zone 5, 8, 7, 8, 9, and then the last segment, which is zone 10. And this is what they do to assembling the laminar strip in a factory. This is the photo of version 3. How come that I cannot make it move? Alright. Well, this is second one, method 2, and the future development, as I mentioned, that you can create a segment with a metal skin, or use the laminar strip as the backbone embedded for precast concrete, or use the metal framing as the mold for cast on site with a membrane or plus a lightweight form concrete. So this is using the laminar strip as the backbone. That's the laminar strip. And this is using laminar strip to create a vertical precast concrete. So you might cut the laminar strip in this shape and assemble it into a shape like that, and then you pour in the concrete and make it become a precast concrete. And this is a perforation panel, which might not be similar to the laminar strip, but is similar to the way of doing a hole cutting. So you can write a program to compose with some circles or some different shape in the panel. And this is a possibility that you have a laminar strip as the backbone, and then you put on the membrane, and then you pour it on, you spread on the concrete, become a structure like this. Some of you may have seen this one. It's a project from another university. They put all the textile membrane and tension it, and then spray on the concrete. Lightweight form concrete and make it cure, and then it can support by themselves. So you see, this is a laminar strip structure. This is a video. I cannot operate. Close. How come that I cannot close it? Okay. So I cannot operate the video, but this is something that you can see. Yeah. Oh, okay.
你可以把这个 window 收起来。
This one? So you can see during the process, you see how they do? It's a laminar strip structure with the edge ring to support the laminar strip. So it's the same logic of the like the mobile strip. You see the post here? So you need some post to support the geometry. It's the same process like when we do the assembly of the mobile strip in the factory. So they are doing wiring. And then they use a membrane. And put on the reinforced mesh. The surface that you see from screen now, that they use tension wire as the base and put on a membrane and then put on the reinforced textile mesh with the lapping. So this darker area, that is the mesh, that's the overlapping of the mesh. And then they do the spray of the concrete. So this is the video from ETH. So we are able to produce a similar or exactly the same structure by using laminar strip and with a different methodology, but producing a similar or exactly the same structure. After you pour the concrete into the laminar strip form or laminar structure. So why are we doing so? Because when in a real projects, we need to think of the possibility of what we can do in a real project. So when you see an image like this, at the very beginning, the designing concept could be like this. And how is the methodology? What is the methodology that you are going to adopt that will affect the cost, the cost and the schedule and the feasibility in the industry. So we might use the same computer program, but by using different material, similar process with different methodology to produce produce a result which is the same, or which looks the same. So this is at the end they unitize the whole curtain wall by aluminum framing and plus a geometry facade as the skin attached on to the main framing. And that is the edge pyramidal beam of the main structure, and this line is the curvature of the facade. This is the visual markup of 2 floors. So this is a very high-end residential building in New York. This is the rear view of the top, from the top to the bottom. This is the picture of doing the erection of the unitized panel. And this is the shape of the pyramidal beam, floor by floor. So if you look at this structure looks very complicated by looking at this photo. Should be okay, you know, should be possible to erect on site. So the methodology the skill is to simplify the main structure and using segmentation and then produce a framing with outer skin. That is the step and strategy to create a spatial geometry for building. Okay, that's it for my introduction today. So at the end, you may think of a way what to choose and what to do and what are you trying to produce with any particular material to create a new product of your own.
Okay, any questions? No questions? Well, thank you, Sam.
You are welcome, everyone. I know it's too complicated for you, but that is your future.
Okay, I think we'll take a break for 5 minutes. And in the last hour, we're going to discuss each team. Make use of this very little break, and then you can share with your teammate. And then I think we can discuss your concept, what you want to do. Okay, and then we can share our ideas and discuss maybe how we dissect the mobile street into 3 zones, and start to imagine what it will be look like after that. Okay, so 5 minutes. Yeah, I think we can start on 3:30. Okay, so we have 40 minutes for discussion.
为什么它分成3个？
对，这是怎么看出来是4个？4个。
我们有做了3个 type。第一个 type 是组装的时候就出问题，第二个 type 是组装的这个中间的鲨鱼鳍，再去组装那个2个旁边的inner wing跟 outer wing，但是在组装的过程里面发现它连接还是会有问题。所以最后才发现说，要把它分割成某一个板块的大小，然后才可以把它组起来。
那怎么找出它哪一个面是要用多大？还是就是去测试把它组出来？
一开始是没有经验的，所以都是用猜的。就是有一个学习过程。那因为我并没有参与，直接告诉他们答案说要这样做，我是让工厂的人自己想办法去
所以他就做了第一版之后，就是发现他煮一小块的咱们的水，然后就要把内框跟外框煮上去，他发现这个框中宽跟中度就变了，所以后来他发现做了第二个方法，把全部的mobile strip那个鳍片都装好，再装上下的这个 rig， 他发现还是煮不起来，最后他就把1跟2的方法综合在一起，他把这个鳍片这个柄做的比较大一点，然后再把这个 inner rig 跟 outer rig 装上，让它有一个长度可以扭曲，就是一个物体太小太短不好扭它，但是都是长一点是比较好扭它。
所以它那个弯度是直接靠它的弹性去弯，还是本来就有？
你是 V 组还是 C 组？
它是完全是电平，
所以木鱼是 V 的。
所以制造的过程很简单，但
好，那
是
等一下我们就
制造的时候
要
就要有3D 的扭曲，那你就会需要对于材料有些知识，因为你不希望用很贵的材料或是很复杂的加工法，所以刚刚你看那个加工单都是一张平的，根本都没有3D，它都是纸的，它是靠扭曲。
无锡人送给你，他写的书不错，他那个是给入门的。
哦，适合我适合我。那
看公司里面说不定可以有同事，哇，看。
上次我们也买了那个谁，何正煌的，也买了很多本。这个我看完都是了，就在。
他这个是从最初阶的，所以他说是手把手。
哦，hand in hand 就是一手交下来 ，OK OK。所以后来我们就把第一版跟第二版他们学到的经验，就是要做成某一个量体之后，有一个长度才好扭曲，所以才会建立第3个版。然后建立第3个版的过程里面，他把那个内环跟外环的强度也把它加大，因为我们现在放在我们台科下面的是没有 post 没有支撑的，是靠那个环的张力去拉住它的。那过程里面已经有很多同学上去做了，所以就已经有载重了，所以它已经有 set 有变形。正常来讲就是说，就像我们做一个建筑体，你建筑体是不是都有梁柱？就有柱子撑住它，再放梁，这样才会成一个格状的结构。但是 mobile strip 你没有看到柱子哦，都是靠张力而已，靠材料本身的弹性，所以这个过程需要比较多的材料知识，像刚刚他们用那个 PTH 用纺织物料加上钢索，它也是加了很多支撑，去把它用张力拉出来之后，然后再把混凝土灌上去，所以它靠的是最后混凝土硬化掉之后的强度，它那个纤维只是当做是一个补强材料，所以你可以用假如里面有纤维，你要用这个竹片也是可以的。
刚好等一下要报告，就是有它混里面纺织物，然后做成它内部结构支撑它，就不需要外部力量再支撑它的结构。
是，但是通常是要熟化之后才会定型，所以你要考虑的是施工过程里面那个活载重，还有材料自己本身的静载重，就是 dead load of the material 它自己的重量，跟 live load of the working process， 所以材料自己的自重跟工作过程的活载重，就刚刚说哦，那我将我这个模具，因为你的用途叫做 mold， 就是模具，我这个模具可不可以先自我支撑？那我混凝土或是别的材料放上去的时候，这个模具还是可以撑住。你只要可以自我支撑，那等它熟化之后，或是各个材料相处就变成结构体。那这个就是一个测试，你都是要用纸张去把它糊成一个面，其实也是可以的。没有人说不行的，因为纸是由木头来的，所以你用木片也可以，就没有任何的限制。那学校的好处就是 没有绝对的对与错，你可以用你个人的方法去做。
那你们之前跟你们的team
你是学建筑的吗？
不是，我是工业设计。
工业设计人对于形貌跟形态颜色会比较敏感，建筑人对于结构性的东西会比较敏感。但是学工业设计的人都是以前，就是说都是技职体系的工业设计的设计工作跟实作会做比较多，他都是高中体系的，可能就是物理化学念的比较多。就是说每个人的底子不一样，但是终究到最后就是我们要做什么事情还是靠自己的兴趣。我以前是念自动控制的，电子。
那差蛮多的。
可是我上班的第一份工作，我以前是只有专科毕业，我就进工厂去做机械的设备的自动控制跟制造，就变成制造工程师。那我就学了，就学了这些制成的东西，就学了材料。所以我是上班了很多年之后，年纪大了才回来念书。那念的材料所是，我就从专科越级考研究所研究所是我们学校的材料所，因为我知道都是考建筑研究所，可能跟不上，因为我没有修法规，我也没修建筑设计。可是我再回头来念建筑设计，那对我来讲已经效益不大。应该说，基本的设计，年轻的同学可以做得比我好。可是要创造一个新东西，就需要跨好几个领域，这个我可以做得比较好。所以每个人的专长不同，但是我可能不会操作很多软体，或是我即便会操作，速度也不快，但是我必须懂大家在做些什么。所以对于跨领域的事情，我就可以做得比别人好，因为我很多方面的知识都有。那我其实也算是做了很多工业设计，因为产品的形貌要改，就先到工业设计，然后要算制程管制，就是做 industrial management， 做 industrial engineering， 然后你做完 industrial engineering 之后，你就要做 industrial management， 所以工业工程变成工业管理，就是这样的。然后做完工业管理之后，把它做行销评估，就是这个东西的产品好不好，价格贵不贵，就要考虑定价。这个在现在做工业设计者就说，你们一定有修行销课程。
我们没有
没有修行销课程。
没有，但是会自己去修。另外
我也所有 MBA 的课程，我以前在产业界经常就上过。那个时候还没有 EMBA 这个名词，但是我们集团有在全亚洲每个国家都有公司工厂，那就筛选了20个经理，就澳洲的跟亚洲的，就筛选20个经理，就开了课，上了1年，再上每个月上1个星期，然后集中在不同的城市上。但是就是你要很累，因为你要牺牲掉你所有的休息时间，因为都是周末坐飞机，然后
所以是各个国家跑。
就全部20个人都集中在每个月在不同的国家、不同的都市。对，那我们有一个 market safari， 就市场探索，就一样有一部车3个人或4个人，就开车出去到不同的地方去。然后你去看看，就这个市场适合做什么，不限制，然后回来提出你的看法。
听起来蛮有趣的。
是啊，思维就不相同了，因为这个已经就不是学校在学这个样子。我们所学的东西是我们的基本技能跟工具。我们是想说，那我会了这个技能跟工具，我如何可以把它传给大家？所以每一个主管几乎都是要去跨领域的技能。所以我来考材料科学其实可以的，但是我第一学期念的也不太好，也不习惯学校的，已经很久没有念了，也不晓得研究所该怎么念。所以第一学期修了太多课，那有一半都不记得。 后来我就跟指导教授讨论，就是建议我说，一学期就修1堂课。假如我不是急着要毕业，因为我的课都是白天的课，就是我选的课几乎都是跟大家一块上的，因为我是一般生考试进来的，我是用中正学历考进来的，那时候还没有。就像现在这个国班有没有在职班这个东西，我是用一般生的身份来，就是说就是来这个时间上课，我就是自己要多数时间来，所以我的工作上就必须要兼顾工作，然后还要上课，这个就得要自己做。因为我是公司的股东，所以还好。因为公司也发现我回来学校学习上课时候所做的事情是完全不一样的，产业的升级才会可能实现。那对于年轻的同学而言，就是说你可以很快的直接进入到一个有机会很顶尖的领域，去把学校学的技术直接用到最顶尖的，不然通常一上班你用的技能大概只有一小部分，不会全部都在做这些造型。
但是现在发展太快了，不一定我们学的是未来需要的。
没错，我以前念书的时候，就是像你这个年纪的时候，我也没学过 AutoCAD，那时候有电脑啊，但是我们写的程式叫是 COBOL， 不是 Fortran 那种很基本的机械语言，没有这些 program 完全没有，而且也没有笔记本电脑，那时候还没有。
那要怎么用那个软件？
那时候只有到学校的实习教室才有电脑。
好，那你们要想一下，当你们想要做这样的构造的时候，
还有学那个逻辑控制，我们有学逻辑控制。工业设计部很多对，设计的部分，那设计部分这方面几乎没有学，但是设计对于色彩啊、造型这些都是比较敏感的。但是跨领域的东西就是不要限制住自己只做什么，你要想办法聚合至少2只脚，这样才增加才会高。
OK， 毕姐，你要不要先把你的档案拿上来，还是你用你自己的电脑？Okay, I think we can start, and we also upload whatever files, slides, or videos onto the Moodle. I think you can publish that on the forum, discussion forum, so that everyone can see your contribution. And maybe we take turn. We start from group A, and then group B, and then group C. Okay.